Back in our project here, I'll open up that side menu again so that we again see that this is basically empty. I do have the VS Code folder with some configuration for my editor, and then only this folder with some comparisons for other programming languages. We could delete this here, it does not hold any Go code. So from a Go code perspective, we still only have one file in here, the first app.go file. Now this is part of the main package, and the main package of your project, the starting point of your project, therefore should be called main, because Go will typically look for such a main package in your project and then a main function in that main package to execute that as a main starting point if you would decide to build your overall project and to run your overall project as a whole. Now, for that, however, we first of all need to create a so-called module, because Go wants to have a module for your project. And at the moment, we haven't created such a module yet, which therefore, as you can tell, works, but is not 100% ideal. To create a module, we can open up a terminal in our project folder, and this integrated terminal, of course, already navigated into this folder conveniently. And here we can run the go mod command, and there the init subcommand to initialize a new Go module. So to turn this project into a Go module, so to say. Now, you also need to give this module an identifier, and this could be first app, but typically you use a URL, or to be precise, you use the URL that would point at the shared source code. So that could be something like github.com if you are hosting your source code on GitHub later, / your org, so your organization name, and then some name of your choice, for example, first app. And you can choose an identifier like this even if that URL doesn't exist yet, and even if you don't own it yet. But if you ever plan on distributing your modules, this should be the URL under which your source code can be found, because that can then later be used by other Go programs to download and import your functionality into other projects. But that's a little bit too advanced right now, so for the moment I'll just come up with some random name like this one and hit enter. Now this created a new Go module, and you can tell that it did that because we now have that go.mod file. In this file, we now have that name which we chose, and we have the Go version that was used or that is installed on our system right now. This can be useful if you ever want to share a module that might be using a slightly older version of Go. Then you can log in that version here. And if a newer version would contain breaking changes that break your code, you would tell Go that your code should be executed with that older version, and hence those breaking changes wouldn't affect your code. But here I'm fine with logging in that currently latest version. Now that's all we need to do to turn this into a module. Inside of our code file, nothing changed. But now with that module created, and this being named main, so this package being named main, and this function being named main, we also have a new way of executing our code. Instead of running a specific file, like this, we can now just run go run dot to run the module stored in the folder in which we currently are. And if I do that, you see it still works, because we turned this into a module, and in there we have a main package named main, which is important because that's what Go is looking for with that main function. So now that's a little bit of a shorter way of executing our code, our module code, with go run dot. And therefore, of course, we must only have one main function in our main package. Now, speaking of that, let's now see how we could split our code across multiple files and then also potentially across multiple packages. Let's say we want to split up our code. I'll keep that one main function in firstapp.go, and we must also only have one main function, but I want to extract this variable and actually remove it from here and move it into a separate file, just to show you how you could split your code across multiple files that, for the moment, belong to the same package. For that, we could cut this variable here, and then you can always also create a variable outside of a function. However, then not with this shortcut here, but instead then you have to use the var keyword and then also, of course, define the type, though you can also omit it here and let go infer the type if you assign a value instantly like this. That would have worked inside of the main function before as well. Now I'm doing it here. So that's how we can create a variable that's not bound to a specific function, but globally available in this package. And hence, we can still use it inside of the function. Here I've formatted the code and saved this file. And if I now run this module, everything still works and we still see hello world, because now we're still referring to that variable, but it's now a global variable defined outside of the main function, but then used inside of the function. But that works as long as we don't use the shortcut. But now we can also cut it from here and create a separate file, maybe named variables.go, in which I just define this variable. Now, this file can be connected to the same package by also adding package main at the beginning. And you should define some package in every Go file that you create. So now this variables.go file is a separate file, but still belongs to the main package. And if you do that, Go is still fine, and you can still refer to that variable in that other file, so in the firstapp.go file, and it will automatically combine these different files that belong to the same package behind the scenes once you run your code. So if I do run my program again, it still works just fine, and it still outputs hello world because these different files that belong to the same package are combined automatically. And that can be very convenient because if you have a file that is becoming rather big and you want to split up your code into multiple files for readability reasons, you can easily do that with help of the package instruction as long as you use the same package name. But sometimes you also want to organize your code into a separate package, which you then might want to use from different modules or anything like that. For organizing your code, that can make sense. If you want to do that, if you want to create a new package, you should create a new subfolder in your project, which you give the name of your package. And that should be a short, concise name that only consists of one word. For example, greeting. That could be my package name. Now I want to put my variables.go file into that package, and therefore I'll drag it into this folder. It's now in that greeting folder. And here I'll now change the package name in the variables.go file from main to greeting. So I'm using that subfolder name. Greeting is the folder name. I'm using that here as a package name. And that is what you should do. You should pick up your folder name here in your package name. Now you'll notice that in firstapp.go, we get an error here. Now Go doesn't find the greeting text variable anymore because code is only shared as long as it is in the same package. Now here we put it into a new package for demo purposes, and therefore we now don't have access to that variable anymore. To fix this, we need to import it. Just as we import the built-in FMT package here, we now need to import our own package. And we do that by importing from our module and then the package. So we always specify the module name, and then we'll add a slash and then the package name. The built-in standard library just is an exception here. This is basically part of a global module, which we don't have to specify separately. But for us here, I would now use github.com So simply that module name, which I have here as a whole. And then slash greeting. That will add the greeting package to this main package. Now still we can't access greeting text, and the reason for that is that just as we have to refer to the package name if we want to access some functionality from it for the FMT package here and so on, we have to do the same for our own packages. So here we now repeat the package name, greeting, and then with a dot we can access the different functionalities that are made available by this package. And now here we have the next gotcha. Remember that at the beginning of this course section, when we talked about variable names, I mentioned that you use this mixed case notation, either starting with a lowercase or an uppercase character. Up to this point, I always used a lowercase starting character, but it's actually not random. Instead, there is a clear rule when you should use what. A lowercase starting character signals to Go that this variable or function will only be used in this same package. If you use an uppercase character, you instead signal that it can also be used in other packages that import from that package. So in variables.go, if I change the greeting text here to greeting text with an uppercase G, I make it clear that this can be imported by other packages. Greeting can be imported, and this variable can then be accessed by other packages. And therefore now here, if I type greeting dot, I can now access greeting text and I get this auto-completion. And that's how I now access functionality like this variable from another package. If I now save everything again, my code gets automatically formatted, and now you also notice something else. That the import code lines here changed a bit. Instead of having two separate import code lines, it's now grouped together like this. And that's simply something which you can do in Go and which you should do, which is why it's auto-formatted like this. Because it simply avoids a bunch of redundant import statements. Instead, you just list all your imports in one long import clause, which you start with an opening parentheses and end with a closing parentheses. And then you have built-in imports first, typically, then an empty line, and then any other packages you might be using, like your own packages. With that, if we run this code again, it still works, and it still prints hello world, but now we also see how we can access data, variables, stored in another package. It's in the same module, always keep that in mind, it's in the same module, but it's in another package of that module. And that's how you can organize your code. And of course, that's all overkill for this basic first demo here. We don't need that extra package here. But these are core mechanisms built into Go, core features built into Go, which we'll use all the time throughout this course, and which you'll use all the time in your project as well. And that's why it's so important to understand what a module and a package is, and how you can share code between packages, and how you can import from packages, and what's up with that starting lowercase or uppercase character here.